компьютер управлять, то ничего никуда не должно
That's one. For somebody come and break the system, yeah.
No, I don't mean this. I mean there will be a person who will beat to hands which move to the wrong direction. So
but yeah, I understand.
The only computer should be used to control.
Yeah, you have to have a robot. Now, in principle, the possibilities are if somebody breaks something in the system, yeah, during running. For example, you have if it's running, you have helium-3 and mixture running all the time. If in this moment you break the line, yeah, it's a problem, yeah. But normally Oxford make a very nice thing. Normally you have under pressure, the tank have 100 liters, and as you see here we have 60, 11 is 71 liters. That means if you open shortly the line, you come to air inside the system because you have under pressure, because the tank is 100 liters, you have 71, you have 0.7 millibars, yeah. That means if you open quickly, it will come air inside. The mixture will not come out, yeah. But of course, if you leave so long time open, the helium-3 is much lighter than air, then it will come out, yeah. But if you open quickly, it will be air inside. That's very clever because yeah, other companies they make with overpressure, yeah. Then as soon you have a leak, the helium-3 come out.
Значит, потом немного.
Да. Ничего страшного.
Потом можно.
Главное, чтобы смесь была.
Потом можно почистить.
Is it necessary to clean after if air will come?
Yeah. You can use the cleaning like we did. We have this cleaning process that I think is here. No. We make one thing here how to clean the mixture. Yeah. You can just circulate through the cold trap. That's why you have the nitrogen cold trap, because why is this dry? The system have no liquid helium. Why you need liquid nitrogen? Liquid nitrogen is only because you have a filter that we call cold trap. It's in principle carbon cold, yeah, and carbon cold can absorb almost everything, yeah. By 77 Kelvin, the only material that's still gas is this hydrogen, helium-3, and helium-4. That means if you have water, air, or whatever in the mixture, yeah, if you pass to the cold trap, the other side can only come helium-3 and helium-4, and the hydrogen. But you don't have hydrogen in the mixture. That means it will come a helium-3. The mixture will come the other side, and on the air will be captured in the carbon. But the carbon should be cold in the cold trap. That's why we have this cold trap in the middle. It's just to clean in case that you have some leak. Yeah, that's what we did for 2 days ago. We tried to clean a little bit the mixture from the tank, because I don't know during this transport from England to Russia if somebody could open the valve or something, and then it's good to clean sometimes. So let's say if I'm not sure if this is really pure helium or pure mixture, or it could be a little bit air, you just clean, you just pass through the cold trap some hours, and then you know that after that you have pure mixture on the other side, yeah. And this is the only part that you need liquid is for this cold trap, because you need to have that.
Жидкий азот нужен для того, чтобы почистить.
And interesting, I can repeat from yesterday. Interesting is you have this pulse tube that I told you to cool this system, yeah, and then important because you guys saw that's a lot of plates. Where I make sense. It's not here, but. I can write maybe as you have the top, yeah, where you have outside, yeah, the system, and then you have the different plates. Yeah, here is the PT1 plate, PT2 plate. These two will be cooled by the pulse tube, yeah. And then you have what you call the steel plate, and then you have a 100 millikelvin plate, and the mixing chamber plate. That's the important. Here you put your experiment. Yeah.
Why steel?
Still, why the name still? Because because we call that you have a distillator there. Yeah, this thing that I explained before, that you pump out the atoms from helium-3 is like a distillation from the mixture. That's why came this word still many years ago. Yeah, and then we call. Because in principle the steel is in the cryostat, but then here is the plates. Yeah, steel plate, 100 millikelvin plate. Because everything you have to imagine, the system is here, with all this tank is here, and you just attached plates in every part of the system. You have the mixing chamber here, and then you attach a plate. And then here we have between the heat exchanger, you attach a plate. It's really a big plate, but the system itself is small. You know, it's only attached to give a good thermal contact with every plate, yeah, and the same here. And the PT1 and PT2 is connected by the pulse tube, yeah. Let's say the pulse tube cool down the PT1 and PT2, and
so this is first stage, and this is the
second stage, yeah. And there's also a plate, yeah. Again, the pulse tube is something in principle small, and then you just connect this part here with the plate, and this part here we connect with the PT2 plate, yeah. And what happens is this tube is cooled down by the pulse tube, but you would like to have that and that cold, yeah. And what you do is this pre-cool. You have a pre-cool line, and what you do with the pre-cool line is just blocks that the oxo put here, and here, yeah. And you have connection between the blocks, go up and go down, and you just circulate here helium, yeah. And what you do is this plate
mixture,
in principle it's mixture, yeah. We take mixture, yeah, and because this plate here is cold by the pulse tube, and this is also cold, and if you circulate helium, you take this cold and begin to cool down this plate, and this plate. You circulate the cold plate from the PT1, PT2 down until the mixing chamber achieves circa 10 Kelvin. You circulate, because here the PT1 plate will be something like 50 Kelvin, like I told you, and the PT2 plate will be 4 Kelvin. Yeah, in principle you cannot achieve exactly, if everything is connected, you can achieve probably here something like 7 Kelvin. Yeah, only if you isolate, but you can achieve below 10. And if you circulate, you come with this cold. You can begin to cool down this plate, and this plate. Yeah, and this is the idea from this pre-cool line. It's just to cool down these 3 other plates, especially the mixing chamber, what is interesting, below 10 Kelvin. But of course, this plate should be cold, and this should be cold, because if you leave these other 2 plates warm, you have a heat load on the mixing chamber. Yeah, that's why what this pre-cool do is to cool down the other 3 plates. Yeah.
Why there is namely 100 millikelvin temperature?
Because
any physics behind
because normally the temperature, if everything cold, is around 100 millikelvin. Yeah, we saw yesterday here the 100 millikelvin plate is 77 millikelvin. But normally we tell because it's around 100 millikelvin. Then we call 100. Sometimes you call 100 millikelvin plate. Sometimes people call cold plate. Yeah, this is only, we are calling now 100 millikelvin because this system is around. And okay, I don't know now how to Olga translate. It's all the time difficult for me because I don't know when I should stop. Yeah, but anyway, you have then the pulse tube to cool down the first 2 plates. And you have this pre-cool line to cool down the last 3 plates, yeah. And as soon the mixing chamber then achieve 10 Kelvin, and then you can evacuate this pre-cool line, because if you leave the helium, the mixture circulating there, you have a heat load, yeah. You don't want to have 10 Kelvin, because if you have gas there, you connect all the plates with a gas. First you have to pump out this gas out, and then you can begin to cool down the system itself, you know. And that's the idea here. The program do that everything automatically. He first circulate. If you see the temperature is below 10 Kelvin, he evacuates this pre-cool line and begin then to put the mixture in the dilution refrigerator itself. That's why I told him it's three systems. One is the compressor with the pulse tube to make this the cooling from the plates, yeah. On the other is the pre-cool to cool the other three plates, and the third one is dilution refrigerator that you cool down from 10 Kelvin to 10 millikelvin. Yeah, and the dilution is the same principle. This first draw.
Here is it 10 Kelvin? Not
Yeah, the 10 Kelvin after the pre-cool, and then you pump out, and then you begin with the dilution free to work, and then it come down from 10 Kelvin to 10 millikelvin. Yeah, because then you use this helium, the mixture, yeah, to cool down. The mixture by the pre-cool is just to circulate. Yeah, it's not to use any property from helium-3 or the helium-4. It's just a gas. Yeah. You could ask why you use mixture, but it's very expensive. Why you don't use another gas? You use just helium-4. But then you have to have two tanks there. You know, one tank only for that, and then they prefer to use one thing to make both. Yeah, first you use the mixture to pre-cool, and then you pump out, and then you use the mixture to really to cool down the system.